Hello viewers, welcome to my YouTube channel Math Freak. This is the second video of our video series CBSE XI Mathematics, and in my previous video I discussed the syllabus and marks distribution. Our today's topic is set theory. This is the first chapter of unit 1. Let me show you the screen. You may write down the informations whether it is necessary. Our today's topic is set theory. Now, what is a set? A set is a well-defined collection of objects maintaining two criteria. I am writing the definition of set. A set is a well-defined collection of objects maintaining two criteria. Number 1 and number 2. Now what does it mean by well-defined? I will discuss it later. First I am telling about the criteria. Number 1, the objects must be distinct. Objects must be distinct, and the number 2 is the objects are independent of order. Independent of order. For example, you can consider the collection of vowels in English alphabet. The collection of vowels in English alphabets, and there are 5 vowels: A, E, I, O and U. Now how do I represent it as a set? We use curly brace to represent any set, and in this blank space we will write the objects using commas. So our set is A, E, I, O, U with the curly brace. And the objects contained in any set are called elements of that set. So each of the letters A, E, I, O, U are elements of the set of vowels. Again, to denote a set, we always use capital letters. So we can name the set of vowels as capital A or B or C, etc. Let it be A, say. Then we can say capital A contains small a. Capital A contains small a. Or we can say small a is contained in capital A, and we will write small a belongs to capital A. Small a belongs to capital A. This is the symbol of belongs to. Again, this set A does not contain the element B. So we can write small b does not belong to capital A, and read it as small b does not belong to capital A. This is the symbol of doesn't belong to. Okay. Now consider another example. Consider example 2. The collection of all positive divisors of 12. The collection of all positive divisors of 12. Then it is also a set, and the elements contained in it are 1, 2, 3, 4, 6 and 12 itself. Now, so the set is this. Let it be capital B. Again, you can consider another example. Consider the collection of all members of your family. The collection of all members of your family. Or you can consider the collection of all flowers in your garden. All of these form sets. Now, let us consider another type of example. Consider the collection of all good boys in your class. The collection of all good boys in your class. Does the collection form a set? The answer is no. Think about it. This collection does not form a set because the collection is not well defined. The collection is not well defined. As the term good itself is not defined here. What do you mean by good? What is the criteria for being a good student? You have to mention the criteria. So, this collection is not well defined and so it does not form a set. But if I ask about the collection of all boys of your class who have got full marks in mathematics in the last class test, then this collection must be a well defined collection and this will form a set. Consider the collection of all boys who have got full marks in maths in the last class test in your class. This collection is well defined and well defined and forms a set. Similarly, if we consider the collection of all beautiful girls in your city, or the collection of all tall boys in your school, or the collection of all honest person in your village, the adjectives beautiful, tall, honest are not defined here. And that's why the collections are not well defined too. So we have learned well defined collection means well defined collection means there must be some rule that will conformly tell you whether an element does or does not belong to that collection. This concept is very important for set theory. Okay. Now take another example. Consider the collection of letters present in the word apple. Sorry. Collection of letters present in the word apple. No doubt this collection is well defined and the corresponding set is A, P, L, E with curly brace. This. Note that I have taken a single P here as I have to maintain the criteria that the object must be distinct. So repetition is not allowed. Here are the criterias. These are the criterias. The object must be distinct. I have to follow this. So repetition is not allowed. There is one more criteria. The objects are independent of order. So so this set also can be represented as P A L E or as E L A P, etc. All of them represent the same set as the elements are independent of order. Suppose you were asked about the set of all students in your math coaching class, and let there be two girls in your class with the same name and title. Another example, consider the set of all students in your math coaching class. And there are two girls in your class with the same name and title. Suppose both of them have the name Rupsha Roy, and you have to avoid the repetition. Then what do you do? Will you take just one of them who is closer to you? The answer is no. In this case, you have to take both of them because there is no repetition as they are not the same person, though their names are same. In this case, you can rename them as Rupsha Roy 1 and Rupsha Roy 2 to make the set. Now you can easily make the set writing the names of the students using commas. That is like Rupsha Roy 1, comma Rupsha Roy 2, and so on. Now we will learn some well-known sets with their symbols. Capital N, that is the set of all natural numbers. The elements are 1, 2, 3, 4, 5, and so on. The set of all natural numbers. Next set is W, capital W, the set of all whole numbers. 0, 1, 2, 3, dot dot dot. These are the elements, the set of all whole numbers. Next set is capital Z. Here the elements are 0, plus minus 1, plus minus 2, plus minus 3, and so on. This set represents the set of all integers. Set of all integers. The next set is uh, Z plus. It represents the positive set of all positive integers. That means 1, 2, 3, 4, and so on. And this set is equal to the set of natural number. Our next set, well-known set, is Q. That is the set of all rational numbers. The set of all rational numbers. Now, what is rational number? A rational number, the rational numbers are those that can be represented as P by Q form, where P, Q are integers and q is not equals to 0. And we use q plus to denote the positive rational numbers. Denotes positive rational numbers. Our next set is capital R. This is the set of all real numbers. Set of all real numbers, and we denote R plus to represent the set of all positive real numbers. Sorry, set of all positive real numbers. I am going to stop the class for today. In my next class, I will discuss about how to describe a set and various types of sets. I will also discuss some mathematical problems in my next video. And if you like my video, hit the like button and share it with your friends, and subscribe my channel for more educational videos. Thank you.